All right, so welcome back to our math video series for your broker pre-licensing course. Recently, we put out videos talking about how to calculate your taxes, how to do tax prorations. We're going to continue this series touching on every single type of math you could possibly see and working through this packet together. So today we're going to talk about area and volume calculations, okay? And a lot of people have a hard time with this because, let's be honest, for some of us, it's been a really long time since we've done school, and of that, very specific types of math like area calculations and volumes and things of that nature. It's not part of our day-to-day lives for most of us. So think way back to grade school or whenever we first got into geometric shapes, and if we're looking at a rectangle, it is just length times width, okay? Length times width. And that's going to give you your area. And so remember, that's represented in square feet. So if we had, 10 feet, let's just say a square, same thing, length times width, 10 feet by 10 feet, it'd be 10 times 10, which is 100, but you don't just say 100, it's 100 square feet. Okay, and so when we're dealing with this type of math is used for measuring of houses. So if you're taking this course in North Carolina, we will discuss the residential square footage guidelines and talk about finding square footage of houses. And I'm sure in your respective states, you'll have something similar. But we also use this exact same type of math for calculating acreage in a lot. Whether it be a rectangular lot or a triangular lot. Now, to be honest with you, most lots are not perfect rectangles. Most lots are not perfect triangles. But for the sake of pre-licensing, we just want to make sure you understand the concept. Most lots are very weird shaped and very weird shaped, oddly shaped lots. And they can cause really big problems in the real world, but that's not the point of today. So when we look here, I just want to point out, let me make sure I get my calculator up here. An example of this. And so if we said that we had a rectangular lot, let me get my calculator to stay on top. So if we had a rectangular lot and I said that it was, 40 feet by 20 feet. All we have to do is take our length and multiply it by our width. Now, folks, don't get so caught up on the words length and width. You could say, if we're dealing with a lot, you could say something like front foot and depth. You could say, this side times that side. As long as you know that you're multiplying one side times the other side, you're good. For a rectangle, for a square, both. So if we were to say 40 times 20, it gives us 800. And so we would say that this is 800 square feet. Now, let's say this is a ranch style house. This would be enough. Okay, we would just say, okay, this house is 800 square feet. If we were dealing with a lot, meaning land, we do not typically talk about land in square footage. We talk about it in acres. And we don't talk about houses in acres, we talk about them in square footage. So the same methodology, but sometimes it requires some conversion. So let me change a little bit of something here. One of the biggest things that you need to remember for this course is a number. No matter which state, no matter which class, no matter where you're taking this, there's a very important number accompanied with a mnemonic to help you remember that number. Okay, and that number is right here on this screen. It is this one right here. This 43,560. And so what that number is the amount of square feet in 1 acre. So if you had a 1 acre parcel of property, and I said, how many square feet is it? We know if it's 1 acre, it is 43,560 square feet. So this knowledge allows us to convert an acre to square footage or square footage to an acre. And so, for example, if we had a lot that was 1.2 acres, well, there is 43,560 square feet in 1 acre. So all you have to do in this instance, let me go back to my calculator, is take your 1.2 acres and multiply it by the amount of square feet in an acre times 43,560. Now, the way that we always help you try to remember this number is the mnemonic 4 old ladies driving 35 and a 60. Now, this is not designed to be, offensive or anything like that. It's just a mnemonic to help. The way that I like to think of it is the Golden Girls. You ever watch that, right? 4 little old ladies driving 45 miles an hour in a 60 mile per hour zone. 43,560. 4 old ladies driving 35 and a 60. And that helps you remember this number. And you do need to know it on the test because it will not remind you on the test. So when it asks you to convert, that number needs to be in your head. So I just converted 1.2 acres to square feet. And so that is the same as saying right here, right? This 52,272 square feet. So let me give you another example here. If we had a lot and it said something like, it's along a road. Now, folks, don't get caught up on what it's along. There is a very common concept called front feet. Front feet makes properties potentially more expensive because they have frontage to a road, like shopping centers, frontage to a beach, lake frontage. So we may use that term front feet. All that's telling you is this side right here. So if we said it had, front feet on the lot of, let's say 100 feet. And then instead of saying, length times width or anything like that, we said, okay, it's got 100 front feet and it's got a depth of 700 feet. Don't overanalyze that. All that's saying is one side is 100 feet, the other side is 700 feet. Now, it is important when we're asking you to price something based on front footage. We'll get into that more in a little bit. But right now we're focusing on area. So in this instance, if we had this lot that is 700 feet times 100 feet is 70,000 square feet inside here. Now, as I told you, if this is a parcel of land, we don't typically talk about it in square feet. We like to convert it to acreage. And so that's typically what the question will say. Something along the lines of, okay, well, how many acres is this parcel that has 100 front feet and a depth of 700 feet? And so now that we found our square footage of 70,000, here's where you need to remember that number. You need to figure out how many times does 43,560 go into this number. Or in other words, divide it by that magic number, 43,560. So we take our 70,000 divided by 43,560. And so that tells us that this parcel of land is, get my red marker here, 1 point, and if I'm rounding, 61 acres. And so that is how these area calculations work. Now, the other thing that may come into play in this section is, of course, triangles. So I want to show you triangles. A lot of people get really intimidated by it because it's not as straightforward as your rectangles or your squares. And I want you to think about something here. We said that the area of a rectangle or a square is length times width. I want you to take a look at this rectangle that I left on my screen. If I was to take my red marker and I was to draw a line as straight as I can from this corner to this corner, what I have done is I have created two equally sized triangles. The reason I'm showing you that is do not overthink the calculation, area calculation formula for a triangle. It is 1/2 base times height. Now, folks, that's just a fancy way of saying base times height and divided by 2. That's all it is. Base times height divided by 2. Well, let's, in that scenario I just gave where this was 100 and this was 700, this is your base, this is your height. So it's actually the same thing as doing length times width for all intents and purposes. And so in this instance, if I said you had a triangle lot and it looked like this red one that I just drew, that would be 100 times 700 divided by 2, or 35,000 square feet. That's it. That's all it takes to do a triangle. It is just base times height divided by 2. And you can see why that makes sense. If you were to cut this in a perfect triangle, right, in half, you get 2 equal triangles. So base times height divided by 2. Now, linear feet is another thing that you may see in here. When we're dealing with linear feet, we mean the exterior of the lot. So in this instance, let me kind of erase my triangle here. If we said, once again, that this was a 100 by 700, well, that means this side is 100. This side is 700, so we'll add that in, plus. This side is 100, plus. This side is 700. So total linear feet around the perimeter of this parcel of land would be 1,600 feet. Not square feet, just feet, because we're dealing with linear footage. Okay, linear footage. So, a lot more concepts to cover in here, but that kind of starts us off to kind of work out some of these problems. And we'll discuss more as we go along. Let me get into some of these here. So, when we look right here, what is the area of a lot with a width of 250 feet and a length of 190 feet? So all you have to do is just visualize it. Folks, you will probably have scrap paper when you're taking your test. You definitely have scrap paper and the ability to do this when you're practicing math. So I would just draw a lot. Okay? And it doesn't really matter if it looks to have the relationship that you want it to, meaning like, oh, it should be only so much bigger on one side than the other. It doesn't matter. The math is going to math. So let's just say that this is 190. This is the 250 down here, which you can't really see. Let me move that. And just put it on the inside. 250. So now we're just dealing with a rectangle. And it's got a width of 250, length of 190. Once again, don't get so caught up on which is width, which is length. It's just one side multiplied by one side. So 250 times 190. The answer is 47,500 square feet. Okay. So if you look at the next one. What is the area of a right triangle with a base of 50 feet and a height of 90 feet? I'm going to slide this over just a touch. The area of a right triangle with a base of 50 feet and a height of 90 feet. All right, well, now we can just draw the triangle out. And so let's just draw the triangle, base. So we got the base of 50 feet. We got a height of 90 feet. Now remember, if you just sit here and you do 50 times 90, and you left it there, that's wrong, because what you really just found is the area of this whole thing, this fictitious square rectangle that's not there. So you have to divide it by 2. Base times height divided by 2, right? Or cut it in half. It's the same thing. So 50 times 90. So our 4,500 divided by 2 would be 2,250 square feet. Ooh, let me get my black pen. That's it. Okay. Now here's where we get into some conversions. How many acres are in a lot 400 feet by 900 feet? So yet again, this is just, if it's not telling you, it's just a rectangle. And so we've got a lot. And we'll just say 900, 400. So 900 feet times 400 feet gives us 360,000 square feet. But that's not the question. The question is how many acres? Okay, how many acres? So this is where that magic number comes in. 4 old ladies driving 35 and a 60. 43,560. So take your 360,000 divided by 43,560 to see how many acres are in this. And so the answer is, oops, black pen again, 8.26 acres. The next one, how many acres in a triangular lot with a base of 250 feet and a height of 300 feet? So you see how this keeps combining the different math concepts. First, we're now finding the area of a triangle. It's going to be square footage, and then we got to convert it to acres, just like we've been doing. So let me just draw you a little visual here, and I'm just going to put it, kind of down here out of the way because I'm going to erase it anyway. So here's a triangle, base of 250, height of 300, and that doesn't look beautiful, but you get it. 250 times 300, that's not the answer because you got to cut it in half for a triangle. So divided by 2, is 37,500 square feet. Still not the answer. Yet again, we want to know acres. So 37,500 divided by how many acres, or how many square feet are in an acre. That magic number, 43,560, gives us 0.86 acres. Now, folks, the beautiful thing about math is you can kind of look at it and see if it makes sense. Because if we know that 43,560 is 1 acre, and we end up with like 30,000 something square feet, it should be smaller than 1 whole acre, and it is. So that looks pretty good that we did it right. Here's where we get into some of the cost analysis, because sometimes you will be dealing with, okay, you found the square footage, multiply it by cost per square foot or something like that. So that's what we've got here. What is the cost of a condo that measures 20 feet by 45 feet at $75 per square foot? Okay, well, I'm not going to draw the rectangle here, but if the condo is 20 times 45, that means that it is a 900 square foot condo. But then we need to figure out how much it costs at $75 a square foot. So multiply that 900 by 75. So 900 times 75, cost of this condo, $67,500. There you go. What is the cost of a lot? 200 feet by 400 feet at $25,000 per acre. Same concept, all right? You've got your lot, 200 feet times 400 feet, which gives us 80,000 square feet, but we want to know the cost per acre. Remember, you can't do apples to oranges. We know the cost per acre, so we need to convert this to acres. So divide by our magic number, 43,560. We've got 1.83 acres. Make that a little prettier. And then you need to multiply that by your 25,000 per acre. So times 25,000, and you get 45,913.68. So let's talk about this last one here. Make sure it doesn't confuse anybody. Property sells for $650,000 that has a width of 125 feet and a depth of 400 feet. What is the cost per front foot? Remember what I was just telling you. Front feet is a consideration in real estate. And so don't let this trip you up. It's not asking for area. So if it's got a depth of 400, that means how far back it goes. And so that means by default, we know that this width, this 125 feet, that's our front feet. Along a road, along something, it doesn't matter what it's along, but it's our front foot. Because our depth goes back from the lot. And so the other number is our front feet. The other thing is when we say these numbers and it defaults to the first number being the front footage and then the second number being the depth. But in this case, it told us, and so we're not playing any kind of guessing games. We're not worried about defaults. And so property sold for $650,000 that has a width of 125 feet and a depth of 400 feet. What does it cost per front foot? So, folks, if we were saying we got 125 front feet times what equaled $650,000. That's all that's happening here. And so remember that what, I told you this is a scary word, algebra. So all you really do is you have this unknown, okay? You can just give it a letter. We just need to figure out the value of A, of R, of whatever letter you want to put in there. Well, algebra says all you got to do is something to one side and do the same thing to the other side to kind of negate it on one and just move it to the other. So if we were to divide by 125 feet on this side, we would need to divide by 125 feet on this side, and that negates itself. So now we know that all we have to do to find the rate or the cost per front foot, take our sold price of $650,000 and divide it by how many front feet there were, 125. It sold for $5,200 per front foot. And I'll just rewrite this too so I can save it for later. There you go. So this is another one of those math concepts that you haven't done for a while. The best way to get better at it is to practice it. Now, do take some solace in the fact that there's not a crazy amount of math on most real estate exams in North Carolina. At the time that you're watching this, I believe it's probably about 7. In other states, it's probably pretty similar, around 8, depending. So don't let it freak you out. Now, there's a lot more practice here. Here's one that I want to talk about for a second that is a way more difficult concept because our brains don't like to do it. So I'm going to show you this, but I don't know if you will actually see these or not. It says it's testable, but just know that it's a little more confusing. So let's talk about it for a second, okay? We've got a building is 87 feet by 150 feet with ceilings that are 18 feet high, but plumbing and HVAC detracts from the usable space because it hangs down 2 feet from the ceiling. The building sold for $4 per usable cubic foot. What was the sales price? Now, cubic, folks, is 3-dimensional. We've been dealing with an aerial view of, square footage thus far, right? The floor plate, if you will. So when we're dealing with a cube, remember the old school way of drawing them, you just put these two and then you've got, this 4-dimensional object. And so just like a building, it's got, base, and then it's got height as well. So when we're dealing with a cube, it is length times width times height to get the area, okay? Length times width times height. So in my fictitious little cube here, let's say that they're all equal sides. It's 8 by 8 by 8 height. So that would be 8 times 8 times 8 for 512 cubic feet. Okay, 512 cubic feet. And so when we're dealing with this, we've got 87 by 150, and then the ceilings are 18 feet high, but we're only dealing with the usable. And so there is 2 feet that we lose because of HVAC, so 2 feet from the ceiling. So really we're dealing with a height of 16. Okay, let me go back here because I've made it all silly now. So it was 87 by 150, and then the height here is 16 feet. So now we're saying 87 times 150 times 16 to give us cubic feet of 208,800. Okay, we got 208,800 cubic feet. And the building sold for $4 per usable cubic foot. So let me erase all this. What we're saying here is it has 208,800 cubic feet that are usable, times our $4 per usable cubic foot. Let's multiply that out. The building sold for $835,200. Okay, don't let this cubic thing screw you up too much. The biggest problem is when we're converting that to cubic yards. And we'll talk about that later because there are 3 feet in 1 yard. And so 1 cubic yard is the same as 3 times 3 times 3, 27 cubic feet. Because if you're dealing with 1 times 1 times 1 yard, that is 1 cubic yard. And so 3 feet times 3 feet times 3 feet is the same thing as saying that. So it's a weird conversion that a lot of people's brains don't like to do. So 1 cubic yard is the same as 27 cubic feet, which makes conversion a little more difficult. And there is an example in this math packet, and I may work it out for you. These are ones that I want you to practice. I'll get you, an answer key. I'll provide this form for you, or it'll be linked somewhere, in the materials. And I'm happy to always work them out later. Let's see. Here is a cubic yard scenario. So let's look at this one for a second. Let's see if I can explain it to you. Okay, so let's work through this one together because this is cubic yards, as I was mentioning, which have a tendency to give people problems because of the way that your brain has to, calculate these cubic yards because of the, 3 feet times 3 feet times 3 feet is 27 square feet or cubic feet. And that's the same as saying 1 cubic yard, because there are 3 feet in 1 yard. So let's work through this, and hopefully I can try to make some sense of it for you, because it is difficult. So what is the cost of a driveway that is 15 feet wide, 40 feet long, and 4 inches thick if concrete sells for $60 a cubic yard and labor is $1.25 per square foot? Now, this is, as I said, apples to oranges. We're doing calculations with square footage and calculations with cubic yards. So make sure that you keep those separate. Remember, square footage is just length times width. Cubic is length times width times height. So you got to do this in kind of 2 pieces. So first, let's do the cubic, because that's a little bit harder. So we've got our 3 numbers here, right? Width, length, height. 15 feet, 40 feet, 4 inches. Now, folks, we could convert all of this to inches, but that's a whole lot extra work. So when we look at 4 inches, folks, there are 12 inches in a foot. And so it is like saying 1/3, right? 4, 8, 12. 4 inches is 1/3. And remember what I told you about fractions. Fractions are just their own standalone mathematical equation. So if I come into my calculator and I say 1 divided by 3, that tells us that 4 inches is the same as saying 0.3 repeating feet. And so we can work with that. So 0.3 repeating for the 4 inches times our 40 feet times our 15 feet gives us 200 cubic feet, okay? 200 cubic feet. Now, remember, you can't just say divided by 3. You're trying to figure out how many cubic yards go into this, but 1 cubic yard is 27 cubic feet. So you would have to take this 200 and divide by 27, which is how many cubic feet are in 1 cubic yard. So 200 divided by 27 gives us 7.41 cubic yards. And then the cost per cubic yard is $60. So 7.41 times 60, which gives us $444.44. Now, the other piece of this is the labor. Folks, please don't get confused, because we looked at cubic feet just a second ago. This is based on square feet. So our square feet is just our length times our width. So 40 feet times 15 feet gives us square footage of 600 feet. Or should I say square feet? And so 600 square feet times our cost per square foot, 600 times 125 should be 750. And so 750 plus our cost for the concrete of 444.44 should give us C, and it really just comes down to rounding, folks. This worksheet is based on rounding to 3 decimal places, and I didn't do that. It's the 0.33 piece that changed it, because if I would have done 15 times 40 times and then just 0.333 instead of left all of it in there, you end up only getting like 199. Yeah, it all comes down to rounding. Not a big deal. It will never come down to rounding, folks. The general rule of thumb is just, round to real numbers, 2 decimal places. Of course, that's the closest answer we've got there. And so you don't need to worry about rounding on the test. It will tell you either how to round or, there will never be an answer close enough. And so if I was to just drop it down to 0.33, which is not as accurate as 0.333 repeating for that cubic feet, would have only given me 198 cubic feet. And then obviously then divided by our 27 would have given us just 7.33 cubic yards times 60 would have given us 439.80 plus our cost of 750 for the square footage. There you go. So they just rounded it differently. Don't panic. Rounding, it will never come down to that. in any way, shape, or form. I do want to make a note here while we're looking at this worksheet, and what I'll do is I'll probably just leave this one out here. This right here is dealing with the government survey system, sometimes called the rectangular survey system. In North Carolina, we've been told that there is no longer math based on the government survey system. So don't stress yourself about this. That's what we've been told. You will not see math on the government survey system if you're in North Carolina. If you're in other states, you may. And then, you know, I may put some additional videos out there for this. But there you go. There is your basic area calculations. Remember, area calculations you can use for finding square footage of a house or finding your acres in a lot. Same math, it's just a little bit of conversions back and forth. You could see, you know, things linear feet, you could see front feet, you could see depth, you could see cubic feet, you could see cubic yards. Yet again, just like any other math concept, practice the different options, especially the ones that you find more difficult, and see, you know, how you can work through it to get better at it. We've got lots more resources. Look for more videos to come out in the future. And as I've always said, we're happy to help any way we can. Good luck.